Regulators face a persistent structural problem. The systems they govern evolve at a rate that immediately outpaced the legal definitions written to contain them. Early governance models tried to solve this by creating explicit feature lists. They attempted to itemize every specific technical capability a system might possess to determine if it qualified for oversight. Because machine learning adapts mathematically, those static technical lists became obsolete almost as soon as they were published. Auditors were left trying to check boxes against capabilities that had already mutated. Alongside rigid lists, these early frameworks relied on floating concepts of human control. They mandated human intervention, but never defined the numerical or procedural limits, leaving compliance officers to guess when a system crossed into high-risk territory. Combining static feature lists with undefined human control limits created massive regulatory blind spots. Conventional machine learning systems easily slipped through these gaps by operating just outside the literal definitions. If the foundational definition of what constitutes an artificial intelligence is ambiguous, any subsequent compliance audit fails at step 1. You cannot govern a system you cannot reliably define. This chart maps the structural foundation of the revised DGPSI framework. It abandons feature hunting entirely. Instead, it introduces a dual access model. Oversight is triggered along 2 lines: a demonstrable loss of human control on the x-axis, or emergent generative capabilities on the y-axis. This removes the subjective debate over what AI is or how it thinks. The DGPSI model operates as a procedural tool built specifically for actionable auditing. To see how this functions in practice, we need to build this definition into a sequential operational decision tree. Translating this architecture into auditable Boolean logic gives compliance teams definitive yes or no answers when evaluating complex systems. Step 1 of this audit is the gate. This flowchart illustrates the filtering mechanism that separates standard software from potential AI systems. To pass through the core definition gate, the system's output, whether decisions, predictions, or content, must not be fully predetermined by explicit, human-authored instructions. Second, the system must actively derive or adapt its own processing logic directly from data, models, or probabilistic methods. Legacy frameworks suffered from a flaw called code-correcting literalism. They operated under the assumption that a system had to rewrite its own source code to qualify as adaptive. The revised DGPSI framework corrects this by establishing that adjusting internal mathematics, like parameters, weights, embeddings, or operative prompts, satisfies the adaptation requirement. This ensures standard, hard-coded software is excluded, while capturing conventional machine learning that adjusts computationally, even when its base source code remains untouched. Once a system passes the gate, it hits the second step, this horizontal barrier representing the accountability threshold. This step measures the exact degree of meaningful human intervention present in the formation of the system's output, or the application of that output to a real-world decision. Previous standards mandated human oversight, but failed to define how much control was adequate, leaving a floating threshold that deployers could arbitrarily define. The new DGPSI standard introduces procedural determinism. The deployer is legally required to define and document the exact point at which human control falls too low for every individual system. The enforcement is immediate. If this specific risk documentation is missing, the threshold is automatically presumed to be crossed by default. A deployer can no longer point to vague human oversight to bypass compliance. Without explicit, documented control limits, the system is subject to full AI governance. Systems that cross the accountability threshold are then sorted into this Venn diagram, containing 3 distinct classes split across 2 axes. Class 1 captures adaptive systems. These models alter their decision behavior on the fly without a human developer reviewing the logic for every parameter adjustment. Class 2 covers autonomous action systems. Here, the system's outputs are applied directly to a decision affecting a person, business, or legal outcome, without a human able to override that specific output before it takes effect. Classes 1 and 2 sit squarely on the control axis. Governance is triggered because human intervention in the loop has dropped too low. Class 3 encompasses generative and effective systems. This targets models generating novel content, like text, audio, or code, or that simulate human emotional states. Unlike the first 2 classes, Class 3 introduces the factor of emergent risk. The outputs of these systems cannot be reliably predicted simply by tracing their initial inputs. This places Class 3 entirely on the capability axis. Governance here is triggered strictly by what the system is capable of producing, independent of how much human control is wrapped around it. Separating these classes along two axes forces an accurate audit. It recognizes that compliance risks stem both from automated decisions executing without oversight and from generative models deploying unpredictable power. A common error during an audit is treating these three classes as an ascending scale of danger. Assuming a Class 3 system is inherently more hazardous than a Class 1, they are actually cumulative risk factors. Because they are independent but overlapping, a single complex model can simultaneously occupy multiple categories. When a system falls into overlapping classes, the compliance obligations for each stack directly on the deployer. The overall severity of oversight, whether low, medium, high, or critical, is determined by a separate risk tier assessment, not the sheer number of classes triggered. An agentic generative tool cannot escape strict obligations simply by maintaining human oversight in one area. Its cumulative capabilities across the classes, measured against the independent risk tier, dictate its final compliance burden. Stepping back, the entire revised GPSI standard collapses into a single continuous operational flow. An AI system is an automated data processing system whose logic isn't strictly predetermined by human-authored instructions. It falls under governance the moment meaningful human intervention drops below a rigidly documented accountability threshold. And that threshold is presumed crossed if it adapts without per-change revision, applies autonomous decisions without manual override, or generates novel and effective content. This short-form summary serves as a checklist for an auditor, translating complex policy into a series of objective procedural steps. The internal consistency of this logic tree serves a larger purpose: global interoperability. The core boundary of the revised DGPSI definition was engineered to mirror the exact descriptive boundaries of the EU AI Act and the OECD framework. It also aligns with the draft framework of the Supreme Court, ensuring legal harmonization across jurisdictions. By adopting this dual-access model, auditors align their internal oversight with the specific requirements of a converging global landscape.